A variable is any letter that we use to take the place of a value in a problem. Say x, we use x as a variable. We can add variables just like we would add real numbers. So say we had x plus x. X plus x is equal to 2x. And let's say if we had 3x plus 2x, 3x plus 2x, that would give us 5x, right? Because 3 plus 2 is 5. Another way we can think about it is with this problem here, we can say 3 of x plus 2 of x is equal to 5 of x, right? It's like you have them all and you're adding them. And so with this, it's 1x plus another x is equal to 2 x's. It's the same as basic addition. Let's say we had 5 times y minus 3y. We can subtract variables just like real numbers also. So what's 5 minus 3? 5 minus 3 is 2. So we have 2 y's left. Let's do another one. Let's do the letter z. Let's do 15z plus 7z minus 6z. So how do we do this now? Well, we can just add it and subtract it like it's real numbers. So if we have 15 z's and we're adding 7 z's, that gives us 22. And then 22 z's minus 6 z's gives us 16z. And so as you can see, we can add and subtract variables just like we would add and subtract real numbers. But what do we do when we have more than one variable? Well, in this expression, we have x's and y's. So I'll show you all we have to do is we combine everything that is the same. So all the x's we're going to add up, and then all the y's we are also going to add up. But first, let's just rewrite this expression with the x's side by side so that we can see how to add them better. So we have x plus x, and then we have plus y, and then plus another y, right? And so now it's a lot easier to see what we're left with. We can just add x plus x, which will give us 2x. And then we have a y plus y here, which will give us 2y. And that is our solution for this expression. Once again, what we did was we combined all the x's into one term here, and then we combine all the y's into one term. Once again, a term is just a piece of the expression. Like these are all terms, and then these are terms, and these are terms. But this is our solution for this example. In this example, we can do the same thing. We have a certain amount of x's, and we have a certain amount of y's, and then we're also left with just a real number. So we can add up all the real numbers together also. But let's do our first step and group all the like terms. So we're going to let's find all the x's. And here's a little trick. When you're rewriting the expression, if you want to just cross out whatever you've already put into the new rewritten expression, that helps me a lot. So we're going to add up all the x's. Here's an x, so let's cross it out and do it there. Any other x's? No. So now let's do the y's. So if we start from the left, here's a 4y. 4y, and then, there's a negative y. So any otherwise, nope. And then now, all we're left with is -5 here. So now we can just do the addition and subtraction problems to keep simplifying. So what's 3x plus x is 4x, and then we have plus, well, what's 4y minus 1y is 3y, plus 3y, and then we have -5 over here. So I'm just going to take this and write it neater down here, but that is our solution for this example. So in this example, we have 3 different types of variables and real numbers. So we're going to do this just like we did our last examples. We can just group all of the like terms and then finish the addition and subtraction problems. So let's start with, we can start with our real numbers. We have a 1 over here, cross that out, and then we have a -1 over here, cross that out, and then we can do, let's do our x's, let's just go from left to right. We have an x there, and then we have a plus x here. Any other x's? No. And then we have a plus, we have a minus y there. So plus minus y, and then we have a plus y here. Cross that out. Any other y's? No. So let's do the z's now. So plus, we have 2z. Cross that out, and then minus 2z. Cross that out. And we took care of all the terms. So now we're just left with a bunch of addition and subtraction problems. Well, let's start over here. What is 1 minus 1? That is 0. And then what's x plus x here? That gives us 2x. And then what is minus y plus y? That is 0y, which 0 of anything is just 0. It's the same as saying -1 plus 1. And then over here, we have 2 times z, -2 times z. So that also gives us 0z, which is also equal to 0. And so we don't need to write the zeros, so we're left with just 2x, and that's our solution. And that is why we simplify expressions, because sometimes something big and long like this can get turned into something a lot simpler to work with, like just 2x. Here we have an example where our terms are variables that are multiplied by each other. And let me show you a way to make this a lot easier to think about. So any combination of variables, just think of it as one big variable. So we can combine the xy's into one basket, and then we can also combine the yz's into one basket because they're like terms. So if we rewrote this as xy, and then do we have any other xy's? Well, there's 2xy here. And then let's do yz and see if we have any other yz's. And we do. We have another plus yz over here. So now we can just add them, just like they're variables, because it's just basically a big variable when you have multiple variables times each other. As long as they're the same combination, you can add them up. So 1 of these plus 2 of these gives us 3 of them, so 3 of x, y. And then we have over here, we have 1yz plus another yz, and that'll give us 2 yz's. So I'm just going to rewrite this down here closer together, and that is our solution. So in this example, we're given a very long expression with lots of different combination of variables, and we're just trying to simplify it. But let's just start bringing it down, and let's see if we can find any like terms that we can add. So I'm just going to start with this 3a squared b, cross that out. And once again, we can just think of the combination of variables as one big variable. And so we're just adding everything that has this combination of variables. So is there any other a squared b's here? Yep, there's one. So just plus a squared b. Any other a squared b here? Nope. So we're going to close that. And then we have, down here we have, let's just keep going from left to right, 4cd. Cross that out. Any other CDs? Yep. There's a minus CD right there. Minus CD. Let's keep going from left to right. And we have a 5a here. Plus 5a. Cross that out. Any other 5a's or a's? Sorry. Any other just normal a's? Nope. And then we're just left with minus 1. So now we can just complete the addition and subtraction problems. So what's 3 of a squared b plus 1 a squared b is 4 a squared b. And then we have a plus, what's 4 cd minus 1 cd is 3 cd. And then we have a plus 5a, and then a minus 1. So that's our solution. I'm just going to rewrite it cleaner down here. Plus 3cd plus 5a minus 1. And that's our solution for this example. Once again, how we simplified is we just went through and started bringing down each term. Remember, a term is this, 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 this. We started bringing them down, and then we looked for like terms, which means the same combination of variables that we can add or subtract into one term. So we brought it all down, did the addition and subtraction problems, and then that gave us our solution.
Hey guys, if this video has been helpful to you, click the link in the description to get access to the complete Easy STEM Algebra 1 system, which includes a textbook, homework, and all of the course videos in order.